The correct sequence of reagents used for the preparation of a particular compound is asked for us in the form of a question, and the question is present like this. Here question is regarding the formation of a particular compound, as we informed in the early. That particular compound is 4-bromo 2-nitro-ethyl benzene. If I write the structure, this is benzene, whereas this is consisting at its fourth place bromine, and at its second place this is consisting nitro group, whereas originally at its first place it is consisting of ethyl group. Here it has to produce 4-bromo 2-nitro-ethyl benzene, whereas by taking benzene as starting material we have to go for the different steps like bromination, nitration, acylation, as well as the reductions, that is bromination 1, nitration 2, followed by acylation and followed by reduction, like this. This is not 1, this is A, this is B, and this is C. Then what is to be done in the beginning, what is to be done in the next and the last to get the corresponding required product, that is 4-bromo 2-nitro-ethyl benzene. After a thorough observation of the product and the corresponding structural analysis reveals us it is consisting groups like, that is benzene consisting groups like ethyl, nitro, followed by bromine. Whereas this ethyl group is orthopara directing, bromine is deactivating group, but it is also ortho and para directing. It is activating group as well as ortho para directing, and this particular group is deactivating group followed by what? Meta directing group. So therefore, if I take this particular nitro into reference as first, it doesn't works because one comes at its meta place, but I can't place other group at its ortho position. If I take bromine into consideration, bromine is a deactivating group. With the deactivating, and moreover it is also ortho para directing, I can't get a group like nitro at its meta place. Hence these two will becomes not suitable, hence I will go for ethyl. Suppose if I go for first acylation, I will be getting acyl benzene. If I go for reduction, that is converted as ethyl benzene, whereas this ethyl benzene is obtained, whereas ethyl benzene is ortho para directing group. Suppose if I go for nitration first, that is having a chance to be substituted as major product at its para place, hence I will go for bromination, then bromine will come as major product at its para position. Then if I go for nitration, then this particular one is activating, this particular one is deactivating. Activating works, activating group is ortho para, para position is blacked, hence remaining two ortho positions for whichever side that NO2 comes, it works. So therefore last I will apply for the nitration. Thus this sequence of reactions might works good for the expected product of formation, that is 4-bromo 2-nitro-ethyl benzene. If I write these sequence related reactions over the benzene and consequences of the product and the intermediates formed in the mid of transformation, it appears as, yes, let us take the starting material benzene. This is our benzene. This benzene is allowed to react with acetyl chloride, that is CH3 COCl, in presence of aluminum chloride. Aluminum chloride is a Lewis acid, so therefore here acyl cation generation takes place. Acyl cation is stable electrophilically. It makes an attack over the benzene at any place, that it is acyl benzene formation takes place. This is step 1, acylation is completed. After this acylation, we will subject this one for the reduction, Clemmensen reduction, that is ZnHg followed by HCl conditions. Thus this C double bond O group is reduced to CH2. So therefore this becomes as CH2 followed by what? CH3. Ethyl benzene formation takes place. Reduction is completed. Then we will apply this one for the bromination, that is Br2 followed by FeBr3. Otherwise Fe. Then bromination takes place at its ortho para positions. Basically ortho position becomes sterically crowded, hence the preferable position will becomes para position. Hence the major product formation takes place para position to that of ethyl, that is 4-bromo-ethyl benzene formation takes place. This one subjected for the nitration, that is a combination of HNO3 followed by sulfuric acids combination is added. Nitration mixture, it is known as nitration mixture. NO2 plus is generated. That NO2 plus, here this is orthopara directing activating group, this is deactivating, this is also meta directing group. All these favors either this place or this place, wherever it comes, it works because it is symmetrical system. This is ethyl, this is bromine, followed by this particular position is getting substituted. This is our required compound, that is 4-bromo 2-nitro ethyl benzene formation takes place in a proper version without much other compound as byproduct, without much loss of the compounds. Atom economically we will reach towards the product. Another question regarding the number of hybridized orbitals present in case of benzene, and the question is present as the total number of sp2 orbitals present in the case of benzene are of how many in number. Whereas benzene formula, if we analyze, that is C6H6, whereas the structure of benzene, if I write the Lewis structure, one of the valid structure of the benzene is like this. This is benzene, this is benzene. Whereas this carbon is having one pi bond, this carbon is having one pi bond, this carbon is having one pi bond. All carbons are having one pi bond, implies all are of sp2 hybridizations. There are 6 atoms. The total number of sp2 orbitals on each carbon atom are 3. So therefore there are a total of 18 sp2 orbitals are present inside the benzene molecule. So inside the benzene molecule, the total number of sp2 orbitals involved in the formation of one molecule of benzene, that is one molecule of C6H6, is given by 18 in number.